All right, sum and difference identities. These are in your flip book. They're also at the top here. Notice I made a note. You do not have to memorize, but memorizing is always helpful, so I'm never going to tell you no on that. So let's dive in why we would ever use these. So notice in example 1, I have cosine 70 times cosine 40 plus cosine 70 degrees times sine 40 degrees. If you'll notice, cosine of one and cosine of another plus sine of that one and sine of that other is the same, and it's a plus in the middle, is actually this identity. Okay, so if we say that alpha is 70 and beta is 40, then that means that we actually have cosine of 70 minus 40, according to the identity. Why is this helpful? Because then I have cosine of 30 degrees. All right, notice off to the side here, I made a note to save some time. I already drew it out. This is, our unit circle, the first quadrant. The first one is 30 degrees. Cosine is the x value of 30 degrees, so that must mean that cosine of 30 degrees is square root of 3 over 2. So again, having your unit circle next to you would probably be helpful right now to help you out. Okay, keep on going. At the end of this video, I will go back and fill out all of these notes. So if you want to go back and look at more, go ahead. But to keep the video shorter and for you to just get the main things down, I wanted to keep on rolling. All right, so then here's where we use it often. If I ask, find the exact value of cosine of 15 degrees. Well, I can type that in my calculator, but calculator is only going to output a crazy decimal. However, I can think that, 15 degrees is the same thing as 45 minus 30. And 45 and 30 are both on the unit circle, which is helpful. So what you want to do with that is then think, okay, cosine minus, go up to the top here, scrolling. It happens to be the one we've already looked at, same one. So it's cosine, cosine, sine, sine with a plus sign in the middle. So cosine of 45 degrees times cosine of 30 degrees, don't really know why I made that 3 small, plus sine of 45 degrees, sine of 30 degrees. Now, see if I can scroll out here without making it too small. Still looking at that unit circle there, cosines are the x values, so I have square root of 2 over 2 times cosine of 30 is square root of 3 over 2 plus sine of 45 is square root of 2 over 2 and sine of 30 is 1/2. Remember, cosine is the x value, sine is the y value on the unit circle. Okay, so then I have square root of 2 times square root of 3 is square root of 6. Square root of 2 times square root of 1 is square root of 2. Oh, and that's not over 2, it is actually over 4. So you can write it like this, or you can write it with the common denominator of 4 so that it's all over 4. Okay. Next, these verifying identities I feel like are pretty easy because nice things typically happen. So I see that this is a sum or difference. In this case, it's difference and it's sine. So scrolling back to the top or looking at your first page, I know that sine and subtraction looks like sine of the first angle times cosine of the second angle minus cosine of the first angle times sine of the second angle. And that has to equal the annoying sibling cosine x. Okay. The unit circle pi over 2 at pi over 2 is 90 degrees. Sine there, which is the y value, is just 1. The x value at 90 degrees is 0. So therefore, cosine of pi over 2 is 0. 0 times anything is just 0. So now I have cosine x, because 1 times cosine x is cosine x. 1 minus 0, well, that's not necessary. So cosine x equals cosine x. Okay. And the hardest ones are anything in radians, and it's not because it's really any different, it's because majority of the time we hate fractions. Okay? Because if I ask you what are 2 different radians on the unit circle, so 2 of the different fractions with pi in it, that add together to get 5 pi over 12, most of my students would stare at me blankly. I love you, but I'm just being honest. So that's the part that makes this hard. If you can tell me right away, you're like, yeah, duh, that's pi over 6 plus pi over 4. You have a great understanding of fractions, and I'm so proud of you. Now, this example made it a little easier because they gave you what the 2 things that add together to get 5 pi over 12 is. So since I want to find sine, I'm going to find sine of pi over 6 plus pi over 4 because, hey, that actually is 5 pi over 12. My identity says that that is sine of pi over 6 times cosine of pi over 4 plus cosine pi over 6 times sine of pi over 4. Now, I've already done examples like this, or done an example like this and using that unit circle, so I'm actually going to skip the work and ask you to check yourself, so hit pause on the video and see if you can get the answer, square root of 2 plus square root of 6 all over 4. Okay. Let's see. And the last thing that I'm going to share in the video, again, if you want some of the other notes, I will have them all filled out, is tangent. This one typically takes a hot second, so if you need to hit pause and stretch, please do so now. All right, so again, they helped you out, except there's a typo there, and told you that alpha is 2 pi over 3 and beta is pi over 4. Okay. If this is my equation, or the identity from the very first page, all I did was rewrite it below here just so that we had it. And I use that, I'm going to get tangent of 2 pi over 3 minus tangent of pi over 4 all over 1 plus tangent of 2 pi over 3 times tangent of pi over 4. Okay, remember tangent is y divided by x. So side note, tangent of pi over 4 is just 1 because square root of 2 over 2 divided by square root of 2 over 2 is 1. Tangent of 2 pi over 3 is negative square root of 3. Again, that's y divided by x, so that's negative square root of 3 over 2. I lied. That one's positive. Square root of 3 over 2 divided by negative 1/2. That's the same thing as multiplying by the reciprocal. So just negative square root of 3. Okay, so that's all unit circle knowledge. Plug and chug here so that I have negative square root of 3 minus 1 all over 1 plus negative square root of 3 times 1 That's negative square root of 3 minus 1 all over 1 minus radical 3. We don't like the radical in the denominator, so we have to rationalize, and this is the part that is terrible. To rationalize, we need to multiply by the conjugate. That means where it was plus, it is now minus. Well, I actually said that backwards. This was minus to begin with, so our new one is plus. What that does is create a difference of squares so that in the denominator, we just get 1 minus 3. Don't believe me, FOIL it all out. Pause here and FOIL. I'm going to FOIL the top. So first times first is negative square root of 3. The outers is minus 3. The inners is minus 1. And last times last is minus square root of 3. I swear we're getting somewhere. So then we have negative 4 minus 2 square root of 3, because there's 2 of them, all over negative 2. And then I divide. Negative divided by negative is positive. Also, I don't need to rewrite that because 4 divided by 2 is 2. So 2. And then negative divided by negative is positive. These cancel out. I'm left with square root of 3. And you successfully made it to the end of longer notes than what I wanted, but you got all the details that you need.